Ladies and gentlemen, boys and girls, we're going to continue talking about collections. And today we're going to talk about the set interface. We're going to talk about uniqueness, hashing, and ordering. We're also going to talk about when to use hash sets versus linked hash sets versus tree sets. So let's get going. What is a set? A set is simply a collection that does not allow duplicate elements. There can only be one. Sets do not have any indexing or positional access. So it doesn't care about order of insertion. The MO of a set is if an element is absent, add it. Otherwise, don't add it. And you will see. So when do we use sets? Enforcing uniqueness. Like if there's a requirement that there can only be one unique element, this is when you use a set. Fast membership checks by using the contains method. Removing duplicates from a list. Like let's say you just want to get all the unique elements of a list. A set can do this for you. And I do have a coding example of this, so stay tuned. Tracking visited nodes. So essentially it's kind of like, okay, it keeps track of where you're going so that you don't visit the same place twice. And we can go into this in another video. So the first kind of set is the hash set. That's the default that we use. It's backed by a hash table. So there's a lot to unpack there. But essentially, what it means to be backed by a hash table is that it takes advantage of the functionality of a hash table, which is to only allow one key per hash table, because hash tables are key value pairs. So a set, in a way, is a hash table in disguise. The element that is contained in a set is the key in the hash table. But again, I'm not going to go too deep here. There is no guarantee of order in a set. So if you're looking for a data structure that allows ordering, a set is not for you. A hash set does allow one null value, and it's very efficient. So adding, removing elements, and checking the existence of elements is an O of 1. So basically, it's constant time, which is good. That's about as good as you can get. The next concrete implementation of the set interface is the LinkedHashSet. It's backed by a hash table and a linked list. So essentially what that means is that you have the functionality of uniqueness of the hash table. So the hash table allows uniqueness in the set data structure. The linked list adds ordering functionality. So now you can access elements based on order of insertion with the linked list functionality. Oh, and yes, it maintains insertion order. I just said that. But it does take up slightly more memory. The rule of thumb is the more operations you're allowed to do, the more operations you get to do, the more memory you're going to take up. But this is good when order matters, but sorting does not. You don't care about sorting, you just care about order. The next is the tree set. It's also known as a sorted set. So this is backed by a tree map. It's also known as a red-black tree. And what this red-black tree does is that it allows ordering. It allows ordering through some intricate mechanisms, which I probably will end up discussing in a future video. But that's beyond the scope of today's discussion. And another rule of thumb is any data structure, any collection with the word tree in it is sorted because it has some tree map backing it up and doing the sorting. The elements are kept sorted. However, TreeSet does not allow null values. And its operations are O of log n, faster than linear, but slower than constant time. And these tree sets use comparable or comparator for sorting. And this is another topic we'll get into, but comparable is basically is when the class has its own mechanisms for sorting. A comparator is when an outside class or programmer defines the sorting order. But we'll get into that later. So sets, a little review. The table is back. So HashSet, LinkedHashSet, and TreeSet all implement set. HashSet is not ordered, but LinkedHashSet and TreeSet are. LinkedHashSet, as I already mentioned, is ordered by order of insertion, and so is TreeSet. None of these allow duplicates, or else there would not be sets. HashSet and LinkedHashSet are not ordered, but TreeSet is, because it's backed by a binary tree. So yeah, that's it for the table. So how do we choose the right set for you? By default, you're going to use the hash set. Unless you have specific requirements, you're going to use the hash set because it's the fastest and it's the most commonly used. Linked hash set, if you want ordering, but you don't care about sorting, a linked hash set might be the one for you. But if you need sorted data, but you want that uniqueness of a set, TreeSet might be the one for you. Important set behavior. So add is very important because if there's an element that you want to add and it's not already present in the set, it will add it. But another thing you should know about add is you can use it as a Boolean as well. So it has two functions. One, to add an element to the set, which is not already there. And if there is already an element there and you try to add it, it will return false. But if the add operation is successful, it will return true. I will demonstrate this in the coding portion of this video. Equals and hashCode determine uniqueness. Okay? Because if you remember, when we call the equals to method, we're comparing the attributes of the object. And the hashCode determines the uniqueness as well. So you're basically taking the attributes and hashing them. And if the values are equal and the hashCode are equal, then it's a duplicate. There are no index-based operations. Duplicates are automatically ignored. Yes, I think this is about the third time I'm saying this. Commonly used set methods. The add method we already went over. Remove. Contains. And contains is not unique to a set. Anything that implements the collection interface has the contains method. Size, that's not unique either. Is empty, clear, that's not unique either. But these are commonly used methods. As a matter of fact, none of these methods are really unique, but they're commonly used in sets. All right, let's go. We are back in Eclipse. And what we're going to do is we're going to go through a series of exercises to demonstrate the different methods that set uses. So let's uncomment out this first one. So what we're demonstrating here is that sets only allow unique elements. They do not allow duplicates. So we're going to instantiate a set. We're going to try to add Alice twice, and we're going to add Bob, and then we will print out the set. So let's see what we get. My guess is that Bob and Alice will be elements in the set, but there will not be two Alices. Yes, We have Bob and we have an Alice. But Alice is not duplicated. This is a linked hash set. So we want to show the ordering. So this is insertion order. So Alice is inserted before Bob, and then Bob is inserted before Charlie. Let's run this. Okay. So Alice, Bob, Charlie. Okay. All right. Next exercise. Next exercise is a tree set. So this set is ordered and sorted. So this is going to be in alphabetical order. So Alice, it's going to be Alice, Bob, and then Charlie, A, B, C. So let's go. Alice, Bob, and Charlie. All right. On to the next one. So this one, we're going to test our contains method. Of course, it would probably help to uncomment out the stuff before. So we'll save this, run it. Contains Bob, true. Yes, Bob's right there. So the method works. Okay, now here's the exercise that I was telling you about. Using sets to reinforce uniqueness. So we have a set of usernames. Oh, okay, this is a new hash set. And then we're adding three of my favorite superhero names to the usernames. Tony Stark, Steve Rogers, and Thor Odinson. So what we're going to do is print out the usernames before the update. And then what we're going to try to do is add new usernames. So are you able to use Thor? Or can I use Clint? And we'll print out the number of usernames after the update. So the point of this is to show that if you try to add an element to a set that's already present, it won't allow it. It won't allow it. And another point is that this add method returns a Boolean, as you can see here. The return type is a Boolean. And this is the add method. So let's run this. Okay. Use names before the update. So can I use Thor? No. Can I use Clint? Yes. And it added Clint. So here, this not only failed to add Thor, but it returned false. So since it returned false, it's going to say no because of this ternary. I thought it would be nice to make it dynamic. This added Clint. So this method was invoked, it ran Clint, and it returned true. So yes. And we can see that the list of usernames increased in length by 1. All right. The last exercise. So in being consistent with my superhero theme, I have created a list of heroes. And this list clearly has duplicates. Superman is featured twice here. And then we have a set called the Justice League. This is a new hash set, and I'm actually passing in heroes here, using it as an argument. So we're going to print out these random heroes before we convert to a set. So this is the list. This is the set. Let's see what we get. So let's expand this. So we have this list with a duplicate Superman. Oh, and Batman was duplicated too. I didn't even notice that. But here, we only have unique elements. Superman, Wonder Woman, Batman, and the Flash. So there you have it. Now we've learned all about sets and the different kind of sets. I hope that you have learned something. Like this, subscribe. I'm out. Peace.